All right, thank you everyone. So today we have Dr. Kaze Wong, who is a postdoctoral researcher at the Center of Computational Astrophysics from the Flatiron Institute. And Kaze is focused on building open source machine learning enhanced software for fundamental science communities on topics including gravitational waves, observational astronomy, diffusion models, and large-scale deep learning. And today, Kaze will be introducing ShowYourWork, which is a workflow management tool for open source scientific articles. So Kaze, the floor is yours. Thank you very much.
Cool. Thanks for having me. Before I start the presentation, let me make this very clear that I'm not one of the original developer of ShowYourWork, and I'm a big user of ShowYourWork, at least in the past. If going into the future, we'll work on like the next version of ShowYourWork a little bit more. So my knowledge on ShowYourWork is whatever I have as like experience from a user side, and I know some of the guts of ShowYourWork, but that's the idea. So I'm Kaze again. Like, thanks for the introduction. So what is ShowYourWork? But before I talk about what is ShowYourWork, just want to like briefly goes over like reproducibility in science, like fundamental science is quite important. In case people, they get carried away by hype. So there was this picture about almost a decade ago that is taken. It's one of the astrophysics measurement that they look at the very early universe and they measure basically some polarization projection. So you look at the sky, measure something. And at the time, one of the collaboration released this picture claiming they found something before the Big Bang, kind of. So they found signature of inflation, which is a big deal in the astrophysics community. They dropping the mic and said a lot of things. But later on, some people couldn't reproduce whatever analysis that they did, and instead of finding some signature from very, very early universe, they found dust in our galaxy, which is still exciting but not as exciting, and that creates a lot of trouble for the team at the time. And in more recent time, there is this superconductor hype. I think it was last year that people finally claim that, oh, well, not finally, but like for the 30th time, that they claim they found room temperature, ambient pressure superconductor. There was a huge race to trying to reproduce it. People failed to reproduce it, and then the hype died. And I work a lot on machine learning, and in the field of machine learning, it's kind of summarized by this meme that, there's first paper that talk about some very good algorithm, and paper B will say, their result is kind of bad, our result is better. And paper C will do the same. And, you just have, basically people just write paper to diss other papers. And there's usually no concern of whether reproducing paper A or paper B correctly in the paper. But the idea is like trying to reproduce the result in a bad way. So, and so they make their own result looks better. And my point here is to say that, if we're not paying attention to reproducibility, it really makes no sense that like we're doing science. It's more like we're just painting or like dissing each other. So hopefully you get the point that reproducibility, it's not only a good to have, but fundamental to fundamental science. Now, ShowYourWork. What is ShowYourWork? So ShowYourWork, it's a workflow management tool that you can install, and in a minute, I'll show how the product looks like. But basically, the idea is to facilitate researcher to make their article as reproducible, as extensible, and as transparent as possible. And it should be very easy, and it's not that hard. You can, it's a Python-based library that you can pip install, and there's a template repo that like this is the instruction that you'll see on the ShowYourWork doc page, that you install the package. You clone the template repo, and then you can build your PDF article. Now, how does that look like? So now let's dive into one of the products. So this is a paper that I written in 2022 with ShowYourWork. Okay, so you see like kind of like a stem that came from ShowYourWork to say, okay, this is prepared by ShowYourWork. And what the cool thing about these is, so you see this icon throughout the paper. So this is one of them. And later on, you in a figure, let's go to figure. Let's say I generate a figure, right? I have a figure in a paper that talk about some important science. But the thing that I work on is heavily computational. So it's not like people can look at the equation and instantly verify whether that is correct or not. So there are links to the figure they can click, and that should bring me to a script. All right, like this is the repository that we just cloned, at the time that we clone, and build show your work, like build my article with show your work on top of. So this is one of the repository that are on GitHub. And the idea of show your work is every figure, or if you want every equation or every sentence, whatever, but mostly the figure and the table and your paper has code component to it, which is hosted publicly. And so this script here, fully available on GitHub, it's basically the exact script that I used to generate that figure. So now, let me go back to here. So the idea is whatever result I present in this paper, they will always come with at least, whatever effort that we put into making that figure. So this is the repository that holds some of the data that, I actually don't have data in this paper. But like a bunch of script that you can see figure 1, I can make it bigger. Figure 1, 2, 3, 4, that correspond to all of the different figures that I made. And maybe I have a table. Oh, we didn't do it in table because it's already self-contained. So every figure has this GitHub, link that links to how to reproduce the figure. And also, if there's external data that we use, how do I move this around? Hold up. Let's see if we can open Zenodo on here. My internet is a little bit slow. Anyway, so the idea is not only it points you to figure, but like the script that generate a figure, but also if you use some big data set that you don't want the user to like explicitly reproduce, or well, I mean, you can get the script somewhere, but it will be nice if you have the data ready to go for them in case they don't want to run the computation. Then there's a Zenodo link that points to the paper points to, they can just fetch the data and reproduce the figure basically bit to bit. So that's the idea. Show Your Work is a workflow management tool that helps you to do that. So you don't need to put them all together by yourself. And this is just another paper in the interest of time. This is like a newer version of Show Your Work. So the stems goes to other place. But the idea is the same. For each paper, you have a repo that points to a script. And also like this, just the tag. So in the source, there is also the tag file that contain the actual tag and the whole manuscript. So that's good. So that's the idea of Show Your Work. Right. So this is just a link to bring you to one of the repository, but in the interest of time. So to use Show Your Work in LaTeX, let's say you use LaTeX to work with your manuscript, it's actually quite simple. All you need to do is use a package, Show Your Work. And whenever you define a figure, let's see, we'll find the figure. So the usual things, right? Like you have includes graphic, caption, but in addition to that, you now need to write a macro, which is a script, right? That will point to, in the same repo, the script that you use to generate a figure. And this procedure is pretty similar for table or any equation that you want to annotate. So that's the good part of Show Your Work. And I use it quite a lot, and I make sure that all of my students use it because I think it's really helps bringing the transparency across in our article and our paper. There's like a how does it work, page explaining, what exactly is the idea behind Show Your Work, encourage people to figure it out. But yeah, it's basically built like a DAG, a direct acrylic graph, a cyclic graph that know how to track the dependency in your paper. So that's the good part of Show Your Work. And now I'm gonna talk about some of the problems that have Show Your Work and what's the future of Show Your Work. So Show Your Work itself works quite okay, but the problem is Show Your Work does not produce like a container environment or like a log file that keep track of all the freeze all the dependency that you need to reproduce the paper. So at some point in the future, if the dependency of your paper get updated, that you're fetching somehow the newest version, it might have you may run into dependency issue, which some of the collaborator of mine have ran into, and they start get upset by Show Your Work, which is understandable. And the other thing is I personally have beef with, not beef, but I don't like Conda too much, and it's Show Your Work depends on Conda a lot, which brings in all the big binaries and extra dependency, which I personally have a problem with. And fundamentally, this is a little bit more to the core of like what we want Show Your Work to be. The reproducibility is not ideal. So as you may have seen earlier that, okay, if I have some big data that I need to put it on some where like Zenodo, and the user need to fetch the data and run the analysis script. So that's good. But in the end, some people would like to reproduce the data themselves. And sometimes, the data could be big, let's say 500 gigabytes, and not everyone has the computer to produce that. So Show Your Work won't solve that problem, because in the end of the day, some analysis or some simulations are expensive. And how do we track that reproducibility? It's an open question. So future of Show Your Work. So as I said, the dependency may have like an evolving issue, may have length rot issue or something like that. So in the future, we may find some solution that produce like a log file. Maybe we write it in Rust, and that will be better, or some other language to manage the dependency issue. Currently, Show Your Work use a lot of SnakeMake. That's the back end of Show Your Work. And it's like a battery include full-fledged package. But actually, we don't need all of the functionality. So we actually want to make Show Work a little bit more lightweight. That's something that we've been thinking about. Like, for example, building the DAG standalone instead of lumping with all the other functionality. So just to make it cleaner, make Show Your Work cleaner. And finally, so currently Show Your Work has been used for mostly paper writing. We're also exploring whether we can integrate it in more use case. Some people is writing code, or a simple example. Now, can we use this new standalone DAG to build a reproducible example per se? So that's the idea of Show Your Work, and we can go into question, I guess.
All right. Thank you very much. Well, I have a few questions, but I know also Alan raised his hand. I want to open the room for questions. Anyone? If not, I'll go ahead. I mean, I'm asking Alan because I saw you raise your hand before.
Yeah, my question got answered in the rest of the presentation. So.
Okay. So my question is, where do you keep the context in which how all these things are tied together? Because yes, you have the manuscript and some of the tables, some of the tables have pointers to the input data and so on, but do you keep anywhere, how would you know how things are connected to each other?
Yeah, so right now it's mostly this annotator, and Show Your Work has some pretty general assumptions on everything is in the same repo. It's in the path of the script. So if you change on the if you change the directory structure, it may break. So it assumes it's in the script file. So it goes into the script data. You can provide extra length to say that. So there's usually this I think it's ShowYourWork.yaml. So you basically specify, okay, this script depends on these files that it's online somewhere, and then it will go into Zenodo and trying to look for that. If it see that, it will download it locally and use those. So yeah, for example, this paper, we do depends on some data, but you it's a bad practice to upload 4 gigabytes or 5 gigabytes of data to. Well, actually, we did it here. This is small. so we kind of, but for the other repo, I think this one, we do have some data, but you can see the data folder is empty. So whenever you on your local and you run Show Your Work, this ShowYourWork.yaml file will specify the dependency. Okay, I need this HTF5 files. Now go to the related repository, trying to download the file, put them in data, and then you run the script. So yeah, this is kind of powered by what under the hood, the backend SnakeMake, and they have
the workflow system.
Yeah,
I understand. So I think it's pretty cool. There are some of us that are involved in an initiative which is called for research objects, and basically what research objects do is that they collect the aggregations of resources. So there is a very big potential here for mixing both and using arrow crates for interchange, right? while using the definition of the dependencies and so on here. Basically, research objects define the metadata backend and the interchange mechanism, and this would define the workflow connection. And we do have some connections, I think, for SnakeMake already done. So this could be an interesting line to explore. Very nice.
Right.
I don't know if anyone has any more questions, but I still have a couple. So I'm gonna leave 5 seconds for everyone else to ask a question, and then otherwise I'll do a final one, and then we can wrap up, because I know that you said that you had to go early.
Yeah.
So any other questions from the audience? Okay, well then my last question is about PIDs. So the thing is that when you point to a GitHub repository, there is no, right now there is no ensuring that that script has changed from the time that you put it in the paper, from the time that you are actually looking at it, right? It could be a completely different thing.
Right. Yeah, like so that it's now on a good conscience of the user that, like, you publish a release that should point to that. So this is actually an interesting question, because we did at the end, like, submit to the journal. Like, for example, like backpop, where's backpop? This is not working. Anyway, so like these paper get submitted to a journal, all right? And in discussion with the journal, actually say, okay, we need to make sure this has like more permanent present in the internet than, like a GitHub repo, because the code can be modified afterward. What about that? So we do version the entire repo structure as a separate object on Zenodo. And that's like that's the current way to do it. But like, going forward, maybe there's like other ways to, just freeze exactly the version that you see somewhere, or maybe link it to archive, something like that. But like, yeah, we're exploring whatever effort we can do to make that easier on that front.
Okay, oh, very nice. I mean, I've worked in scientific workflows for a long time, and we were always wondering what was the best way of making sure that people writing papers would be able to adopt all these, because you are using a workflow system, but it's under the hood, right? Which is the right way to do it. So I think this is a very, very cool approach. Thank you. Thank you for your time, for your presentation.
All right.
All right, I'm gonna stop the recording now. Thank you.